Hello friends, welcome to Susan and John MathTube. In this video, we learn how to solve a linear programming problem using the Big M method. And as always, the most important question, how to use these video lessons effectively? And I'm sure you know the answer, and I hope you're following all these steps. And with that, let's start the Big M method. Now look at this. Long back, if you look at the last 10 years question paper, you'll see that in linear programming, they will ask you two questions. One is the graphical method and another is the simplex method. And usually they used to ask the graphical method for 5 marks and simplex method for 10 marks. But if you look at the last 1 year, that means the last 2 semesters, you'll see that they didn't ask simplex method, but instead they asked something called the Big M method. Actually, in your syllabus, there are 4 different methods. One is graphical, simplex, Big M, and what you call two-phase method. So if you're planning for very good marks, you have to be very good in all the 4 methods. Otherwise, you may expect simplex method in exam, and finally they might ask Big M method or two-phase method. Anyway, let's learn Big M method. Now look at this. When we learned simplex method, I told you to check whether the problem is of maximization. And I told you one more thing. All the inequations should be in less than or equal to format. But in Big M, there is no such criteria. You can use, the problem can be maximize or minimize, and the inequations can be less than or equal to, greater than or equal to, or even equal to. Okay, so let's start. Now, before we start, the most important thing. You can note this, in maximization problem, what we do is, we will adjust the objective function by adding MA1 or MAI for every artificial variable which we introduce. In the last video, I told about the identity matrix, the basic matrix, like 1 0 0 1 0 1 0. That is how we used to find the solution. Okay, now look at this. There are 2 cups full of water. And it's clear that this side is greater than or equal to. So this side is greater than or equal to. There is more quantity here. And if you want to make them equal, and as I told you in the last video, you're not allowed to touch the right side. You're not allowed to use this or touch this. So automatically you have to spill this water. That means you have to subtract something. I hope you got the point. And these variables are called surplus variables. Now when you introduce surplus variables, the problem is we will not be able to find the identity columns, the columns which are available in the identity matrix. So the identity columns will not be there when you introduce surplus variables. So what we do is, with every surplus variable, we will introduce an artificial variable. And we will keep the cost of such variable in maximization problem as minus m, and in minimization problem it will be plus m. Okay, now look at this, the modified problem. So we are going to modify it a little bit. So the first one is less than or equal to, so I am sure you are an expert with that. So it goes like x1 plus 2x2, and then what do we do? Yeah, plus s1 is equal to 18. So what we did is, we added one slack variable, just like before. Now look at the second one. It might be slightly different for you, but it's the same thing. So the modified problem becomes 2x1 plus x2. Now I'm going to subtract s2, just the next one, s1, s2. At the same time, I will put an artificial. And since it's the first time I'm introducing artificial, I'm putting a1. You can use any letters or any notation which you like, is equal to 21. So that's it. Now the objective function. So P is equal to 2x1 plus 5x2, and the cost of the slack and surplus variables as before, they are 0, but it's a maximization problem, so I'm going to add minus MA1. Now look at this. In case you used two artificial variables, let's say A1 and A2, your answer will be minus MA1 minus MA2. I hope you got that point. Now, as usual, what do? We take everything to the left. So you're going to get minus 2x1 minus 5x2 plus MA1 plus P equal to 0. Okay, so let's go for the initial table, or let's rather call it the initial matrix, because I hope you understood that method. And if you did not watch lesson number 5 and 6, please pause the video right now and learn the simpler version of the simplex method. Okay, so let's start. So I'm going to write the variables involved: x1, x2, one slack, one surplus, and surplus means there will be artificial, and of course our objective function, that is P, and our right hand side, and that's it. That's a matrix, and outside you can write ratio. Okay, so let's start. So the coefficients are 1, 2, 1. 1, 2, 1. This is 0, there is no artificial, 0, and the right side is 18. So it's going to be 2, 1, no S1, surplus, that means there should be an artificial. See, can you see that 0, 1? That's exactly what we want. And again 0, and it's 21. And let's put our separators here and here. Now let's go for the objective, that is minus 2 minus 5m. So we get minus 2 minus 5, 0, 0, m, 1 and 0 as always. Now look at this. Don't skip this step. It's very important. First listen. So what we do is we have to initialize this table in this method. So the advantages, you can use maximization problem or minimization problem, and you don't have to care about whether it is greater than or equal to or less than or equal to. And first you write here initializing or initialize. Now look at this. I'll tell my aim. I have to get rid of this m, then only the table will be initialized. I'll repeat once more. I have to get rid of this m from the objective row, and you don't have to worry. Since m comes along with the artificial variable, there will be always an 1 above it. That's for sure. And remember, in case you're using two artificial variables, which we'll see in some other lesson, not in the next lesson, some other lesson. So in case you have two m over here, you have to eliminate that m 1 by 1. So I'm going to write the operation. So we have R1, R2, R3. So R3 changes to R3 minus M R2. Operation is very simple, and it's really simple. R3 changes to R3 minus M R2. I think you can see that the target is M. It's in R3 minus M R2. So let's start. So minus 2 minus 2m, and then minus 5 minus m, 0, 0 plus m. Of course this will be 0 and this must be 0, 1, and what do you call minus 21m. Now look at this. You can forget about this. So this is what we do for the initial table. So this is our initial table. So I hope you understood this. And remember, m is a very big number. You can treat m as if it is positive infinity, or you can think about m as a very huge number. In some books, they ask the students to test these values by putting m equal to 10,000 or 20,000, but you can just imagine, and that's it. Yeah. Now look at this maximization problem. So we go for the most negative quantity. If it is a minimization problem, we will go for the most positive quantity. Okay, so it's obvious that this is the most negative quantity because it's 2m. It's kind of like saying 2 times infinity. So no one can compete with this number. It's so big in the negative direction. So this is the smallest positive number. So this is our pivot column. Now we have written ratio. So 18 by 1, that is 18, and 21 by 2, that is 10.5. Okay, so the least, so this is the least. So we get 2 to be our pivot element. Now what should we do? We have to make the pivot element 1 and the elements above and below the pivot to be 0. So R2 changes to R2 into 1 by 2. I'll repeat, R2 changes to R2 into 1 by 2. So let's go for the next column. Okay, so no change in the first row. So I get 0, 0, 0 and 18. But the second row is going to change because we are dividing throughout by 2. This is 1, 1 by 2, 0, minus 1 by 2, etc., etc. So I get 1, and don't forget this is our pivot. And 1 by 2, I'll strongly recommend now start doing these operations by yourself. Don't skip the video. It's better that you watch the video completely. So it's 21 by 2. And minus 2 minus 2m minus 5 minus m 0 m 0 1 minus 21 m, and let's put our divider. Okay, now what's the aim? To make the elements above and below the pivot to be 1. So I'll write the operation. First operation is very easy because I can see 1 and 1. So R1 changes to R1 minus R2. And second operation is R3 changes to R3 plus 2 plus 2m into R2. Think about it. You want to make this 0. So minus 2 minus 2m plus 2m plus 2m. So that will give us 0. Anyway, let's fill the table. So 1 minus 1, 0, 2 minus 1 by 2, that is 3 by 2. Then 1, 1 by 2. You can fill the table yourself, but please be very careful. One small mistake and you're going to lose 10 marks. By the way, they asked this question for 10 marks maybe 6 months back. And this is the same. 1, 1 by 2, 0, minus 1 by 2, 1 by 2, 0, 21 by 2. And then let's close our divider. And this will be 0. Uh-oh, bad news. Why is it bad news? Because the table is not optimal. And then minus 1, then 1 plus m, 1 and 21. Okay, now as usual, let's move on to the next step. So look at this. The table is not optimal because the last row is still non-negative. And the most negative number is minus 4. So that is the, what you call, pivot column. And then let's write the ratio. So 15 by 2, that will be 5. And then 21 by 2, that is 21. So the least. So the pivot element is 3 by 2. Now let's go for the next operation, that is R1 changes to R1 into 2 by 3. So we get, so you have to multiply throughout by 2 by 3. So of course it will be 0, 1, now try it. I hope you got this answer. It's very easy. You just multiply throughout by 2 by 3 and no change. Now let's move on to the next step. So don't forget to circle the pivot. The pivot is over here. So we have this simplex table. Now what to do? You have to make all the elements below and above. There is nothing above. So all the elements below this to 0. So let's write the operation. R2, the target is in R2. R2 changes to R2 minus 1 by 2 R1, and R3 changes to R3 plus 4 R1. So we write the two operations. R2 changes to R2 minus 1 by 2 R1, and R3 changes to R3 plus 4 R1. And we get 0, 1. There is no change because we have already made it 1. So just write as such. Okay, now we have to start with the operations. So 1 minus, that is 0, 1. So we get 0. Now minus 1 by 3 and minus 2 by 3 and 2 by 3 and 0 and 8. And let's put our separator, and 0, 0, 8 by 3, 1 by 3, m minus 1 by 3, 1. Finally, good news. And you already know the good news. Look at the last row. It is completely positive. Let's say no negative numbers are there. That means we have reached the optimal table. Now I'm going to write x1, x2. No need to write the rest because I have already identified the identity columns, the columns of the identity matrix. Now I go down and to this side, so this will be x2. I go down and to this side, this will be x1. So the value of x1 is equal to 8, x2 is equal to 5, and the maximum value of z is equal to 41. Now let's try one more problem of the same type so that you're like really confident with the method. Okay, so they asked this question 1 year back. Okay, so solve the linear programming problem using Big M method. I'll repeat. What is given? Solve the linear programming problem using LPP using Big M method. So make sure you read the question properly, whether it is simplex or Big M or two-phase or graphical. So as I told you, we don't have to care about maximize or minimize, or we don't care about greater than or equal to. That's one big advantage of Big M method. And remember one thing, in real life scenarios, people don't solve these problems with pen and paper. They used to do it, maybe 30-40 years they used to do it. Now everything is programmed. You just make a computer program and you can make the computer do your job. So basically you're learning this process so that you can program these things and use it in real life scenarios. But for the exam, of course, you have to do with pen and paper. So let's start. It's less than or equal to. So the first modified equation is, so we're going to write the modified problem. So plus S1 is equal to 10. So we used a slack, and then minus x1 plus x2. Okay, so we need a surplus. Whenever you add a surplus, you have to use artificial. Otherwise, we won't get that identity column. And the profit function, that is p equal to 2x1 plus x2 plus 0s1 plus 0s2, and it's a maximization problem, so I'm going to put minus ma1. If you use a1 and a2, that is minus ma1 minus ma2. Now let's take everything to the left side, so minus 2x1 minus x2 plus ma1 plus p is equal to 0. Let's start with the initial table or the initial matrix. Okay, so I'll write all the variables x1, x2, s1, s2, a1, p, and then our right hand side. And outside you can write ratio, and we can put a divider here. Okay, so let's start. So it's like 1 1 1, yeah, 10. So 1 1 1, it's going to be 0 0 0 10. Now minus 1 1, so it's minus 1 1. This of course is 0, this of course is minus 1, so it will be 1, so 0, and the right side is 2. Now our separator and the objective function, minus 2 minus 1 m. So minus 2 minus 1 0 0, of course m, and 1 and 0. Okay, now how do you initialize it? How do you get the initial table? So let's put one more divider. Look at this. If there is only 1m, we do this operation only once. If you use 2m, we will do this again and again and get the initial table. So I'll write initializing. So look at this. As I told you, we have to get rid of this m. And above m there will be 1, maybe here or maybe here, but there will be m. So here R3 changes to R3 minus m R2, and that's very easy to do. So minus 2, so m minus 2, minus 1 minus m, and then 0, then m. Of course this will be 0, and 1 and minus 2m. So we got our table, and now look at this, just ignore this. Don't cut like this in your exam, but ignore this. And now we have to find the most negative quantity. Clearly the most negative quantity. So this is our column. Now let's go for the ratio. 10 by 1 is 10, 2 by 1 is 2, so I prefer this. No, I'm forced to take this. Okay, so what to do with this one? Yeah, we have to make above and below to 0. So I'll write the operation. R1 changes to R1 minus R2, and R3 changes to R3 plus 1 plus m into R2. I hope you understood this operation, and I want you to do this by yourself, and I'll write the table in a while. So pause the video and try it. Yeah, so I hope you got the answer. You can check it. Okay, so bad news. The table is not optimal. How do you know it's not optimal? The last row is still negative, and we find the most negative, actually the most negative one, and again we find the pivot column, and the ratio, that is 8 by 2 is 4, 2 by minus 1 is negative. Negative. Now look at this. If it is negative, just ignore it. And if both of them become negative, it means the solution is unbounded. Okay, so this is our pivot. So in the next step, you have to make the pivot 1. So I'll write the operation and I'll wait till you complete it. So R1 changes to R1 into 1 by 2. Now I hope you got the table, and don't forget to circle the pivot. So now what's the next aim? To make the elements below and above the pivot to 0. So I'll write the operation R2. The target is in R2 and our pivot is above. So R2 changes to R2 plus R1. That's very easy. And R3 changes to R3 plus 3R1. It's addition, so it's a bit easy. So let's try. So the first row is same. Now minus 1 plus 1, that is 0, 1, 1 by 2, minus 1 by 2, 1 by 2, 0, 6. And then it's 0, 0, 3 by 2, 1 by 2, m minus 1 by 2, 1 and 14. So good news, it's optimal. Finally it's optimal. And now what we do? We find the identity columns. and I'll write x1, x2, x3, etc. But I don't have to write because I already found the identity columns. So this will be x1 and this is going to be x2. So x1 is equal to 4, x2 is equal to 6, and the maximum value of p is equal to 14. Okay. Now I want you to take any book which you like and try more problems, because unless and until you try a lot of problems, you will not be perfect with the method. So once more I'll remind you, you have to be good with the graphical method, which I'm not planning to add in these videos because you'll be really good in this graphical method. And second one that is important, that is lesson number 5 and 6, simplex method. And I'll strongly recommend you go through these videos because this method is slightly easier than the regular simplex process. And the third one is big M method. I told you long back the trend from your past paper questions was like they used to ask simplex method, but nowadays they have started asking the big M method. So maybe very soon they will even ask, maybe this year they might ask the two-phase method. So be prepared with the 4 methods, so you get 15 marks. This linear programming problem is worth 15 marks. And one more very important thing, when you try a linear programming problem, make sure you work out the questions really slow and with a very cool mind. Yeah, okay. So I'll be back with another video and we'll be discussing determinants, because there are a lot of determinant questions and every question will look different. So the only way to be successful in determinants is you solve a lot of problems. Okay, so I'll be back soon. Till then, bye.